don't think you can start a Zoom without saying those words. Okay, we'll get started. So, hi everyone, and welcome to your Thursday evening revision tutorial on biology and chemistry A levels, how to get an A star in biology and chemistry A level with two super tutors, Kavarang and Hiran. My name is Theo. I'm going to be in the background of this, and I'll share some of the questions at the end. So if you do have any questions for either of our tutors about revision techniques, how to approach the exams, and so on and so forth, anything that might come up, please put them in the question and answer function of Zoom, and I'll get to that at the end of the talk so that we can get through. Um, First of all, just to introduce where we're talking to you from and who we are. My name is Theo, so I am head of operations at the Medic Portal and Duke's Tutoring. We are a consultancy based in the middle of London, and we support medicine applicants from all across the world who are applying for UK medical schools and medical schools um, across other countries too. And as you can see, we've supported over 50,000 medicine applicants since 2015. But you're probably familiar with our website, and we have many more visitors to our website than that. We could get the next. Great. We also work with lots of schools across the country and beyond. And we are sisters to a company called Duke's Tutoring, who support with syllabus-based tutoring. So if you're looking for a boost with your GCSEs, or more likely for you guys for your A levels, then that's exactly what Duke's Tutoring can do, either in person, mostly based around London, or online. Brilliant. So just to introduce our two speakers. First up, we have Kavarang, who will be speaking to you for about 15 to 20 minutes, all about biology. Kavarang's background is biochemistry at Warwick and is now a graduate medicine student at Swansea. And believe me, that is a difficult course to get into. And next up, we have Hiran, who will be talking to you about chemistry A level. Hiran is also an extremely experienced tutor and a qualified teacher, has graduated from 3 universities, potentially 4 universities, and is a STEM specialist. So he'll be talking to you all about chemistry A level and how to maximize your scores. So I will now hide in the background and let Kavarang take over and speak to you about biology.
Perfect. Thank you for that introduction, Theo. Nice to meet you all. And like Theo said, we'll leave questions near the end, otherwise I think we'll run out of time. So I think when I was thinking of like the best tips to give you guys, I think a few things came to mind. But I remember these are kind of the echoes I'd got back in like year 12 when it was just, just work smarter, spam past papers, just do a ton of those, learn the mark scheme, of course, print it all, leave it up on your next to your bed when you wake up, just look at the mark scheme. Make sure you revise, of course, look at the spec, do tons of flashcards, and just memorize the textbook, and you'll be fine. And I think at the end of year 12, all this advice kind of boils down to it not being very useful because there's so many different cooks trying to tell you what to do. And I think I've distilled by the end of year 12 and the start of year 13, I realized there's so much content in biology as compared to something like maths, for example. You kind of have to take a divide and conquer approach. And I think, therefore, there's like three main things you want to divide your time into. Number one is the content. There's a ton of content, but you've got a topic list in the specification. You can also find it on other websites online. So get one of those down and write those down. Second, we'll go through some exam technique tips that I can give you. And finally, we'll look at the marginal gains. And I think this is where you'll find a lot of value here. And hopefully we'll get that A star in the middle there. Okay, so as for content, I think first things first. Space repetition is king here. It's really, really important. It's something you might have heard of if you're looking at like if you're thinking of applying to medicine. You might have seen Ali Abdal and a lot of people advocate for things like Anki and space repetition. I think at this stage during your A levels, So having just a spreadsheet and having an idea of like, I'm going to study this specific topic currently, and then 2, 3 weeks later on down the line, I'm going to do a checkup is good enough. Having a spreadsheet to sort of track your progress is really, really important. And you can make them really easily, or you can find templates online. Here's an example of mine on the right. Um, What's more important, though, I found, is tracking all your mistakes. I think on the right there, you can see me doing all of the past papers, paper one, two, and three from all different years, and putting my scores down. What's really important here is I have a track of all of the mistakes I've made, and I color those topics in those respective colors, how many times I've made those mistakes. And then I'm aiming to go through them every time. If you're still struggling with a lot of focus and you're not really sure on which, the topic's too big and you're not sure where a few questions, which topic they might fall into, I would say split the topics into even smaller parts. You can have a look in your textbooks, the AQA or depending on whatever spec you're doing, have a look at the small topic headings, subheadings within your topic to help you sort of split into smaller parts for you. And I think this lets you sort of, like we talked about before, divide and conquer even better, because then you can use something called the blank page method. This is something I like doing to just sort of have an understanding of where I'm at currently, especially at some of you might be in year 12 or year 13. Um, if you're in year 13, you've learned a lot of content and you need to figure out what you know and what you don't know. And sometimes you're in that stage of, I don't even know what I don't know in in those sort of moments, I found it really helpful to just get a blank piece of A4 and just write down everything I know about XYZ topic. Topic one. If you can write down everything you know and have a look in your textbook or have a look on notes that you found online and figure out the things that you don't know, then you have something like you can work on. You can fill in the gaps, and then track down your spreadsheet, and then the whole cycle starts again. Finally, I think what's really important is I remember making really, really nice notes in year 12 and never really looking at them again during year 13 because then you had all this new content to revise and it's really hard to go back to some year 12 topics. And I think here, making questions from your notes is really, really important. You can take pictures or you can, if you made them online, just copy paste it all into ChatGPT, Gemini, etc. And try and use AI to essentially make your notes into small questions for yourself. You're not really looking to get mark scheme answers here. You're trying to quiz yourself on your content and essentially stay tuned in rather than, just blankly looking over your notes. And I found this really, really important to sort of keep my focus. And I hope that helps with your content. Next up, I think exam techniques, probably the second most important thing here. It's one thing to get exposed to a lot of like exams during your mocks and things that you do in school. It's another thing entirely to be sitting there on your own, in your bedroom or living room, all cozy and doing some exam questions without any time conditions. They're two very different things. So I think first of all, you want to make a list of all your exam key like command words. There's a lot of, I mean, they don't really change spec to spec. And I think AQA has on their website, they have a list of what all of their exam words mean, command words mean, sorry. Um, Figure out what the examiner is actually asking through these and what they mean to you specifically, right? So what that means to me is whenever I see a describe question, usually in AQA, that's a one, maybe a two marker. And it's literally just the things that your teachers tell you in class to memorize the descriptions of. This is where they come into play. You know you don't have to memorize mark schemes because you know you've already learned it in class. And this is where you save a lot of time. Second, figure out patterns that repeat over and over again. What that looks like is looking at two markers, two different two markers that are descriptions. What's the differences here? I'm not talking about the topic. I'm more talking about where are you getting your marks? Is it something that's really obvious or is it something that's more harder to remember? Find out the patterns for you because everyone's brain's really, really good at pattern recognition. You just have to get used to those patterns. Finally, I think, oh, this is what we talked about earlier. Highlight the similarities in your mark schemes. And this might be something that you can chuck into your notes to help you as you're revising or making questions from. We talked a little bit about different board exams or different uh, exam boards earlier and how I said they don't really differ that much. So the command words don't differ that much, but the questions do. So try and expose yourself to questions from other exam boards. The reason for this isn't so, you mess up your mark scheme answers or anything. It's more to expose yourself to new questions because when you sit your exams in May or June, you're going to get new question types that you haven't seen before. And more often than not, you'll find that if you do other exam questions from different boards, you're going to find yourself being a bit more comfortable with those questions because you know that you can do something you haven't seen before, especially if you've been through all the exam questions from physics and math tutor, etc. Finally, peel away the context. So this is, I think, something that's much harder to do. Once you've started making a list of all these command words and what they mean to you, and you've started exposing yourself in your practice, new exam questions, try and figure out what the underlying question is. A lot of the times, and we'll go through an example in a second, a lot of the times you'll get a bunch of information about something that doesn't really matter. What topic are they actually targeting? So, an example here, right? This is from an AQA exam paper. This is a bunch of information about damselflies. Now, I'm just focusing on B here because I think it's a really good example. So you've got a lot of information here about some other species have larvae, etc., etc., etc. What I like to do is read the main question first. I know this is an explain command word, so I'm going to have to, one, probably describe something, and two, develop that answer for a second for my 2 marks there. Explain how the presence of gills adapts the damselfly to its way of life. So I'm probably going to have to read this and then think about what I remember about gills, and those are probably 2 marks there. So you can see down here, number one, the damsel larvae has high metabolic and respiratory rate, and you can see that there because there we go. They don't actively hunt prey and they don't have any gills. So how do they help? The fact that they have a higher metabolic rate means that they use more oxygen per unit of time because they actively hunt their prey there. So it's using 2 ideas. I know one, I'm going to have to use something from that description, and second, I'm going to have to use something I know about gills. Cool. Finally, the marginal gains idea. And I think this is really important. A quarter of your exam, your A-level grade in biology, is going to be down to mathematical skills as well as practical skills. So it's really important that you spend the time, drilling those skills. Make sure you put aside that time. This looks like understanding why you're doing your practicals. This looks like making a note of every maths question that you get, especially things like genetics and things, and putting those on the side and making sure you review them every so often to know that you understand how to do most of the maths questions that could possibly come up. That's 10% essentially guaranteed. That's a difference between a grade boundary. Um, Also, like we talked about, familiarize yourself with why you do the practicals, and practice those steps for the key math skills. I think for biology, it's a little bit easier. There's not that much variation, so it's worth spending that time getting those small marginal gains to get yourself to the A star. So, a little recap here. What did we talk about? First of all, we went over the content, some ideas for how to write content, for example. Number one, I think this looks like making an Excel spreadsheet of all the different topics in your board exam, and highlighting where you are currently with them and making a bit of a plan on, I'm going to go through this and this topic this week, for example, and tracking when you do that. And when you do exam questions, make a note of those mistakes. Be very, very true to yourself. Try and be harsh with those mark schemes because when it comes down to the exam, you'll be more pleasantly surprised if you have a nicer marker. Second, with exam technique, make sure that you're exposing yourself to new exam questions and you understand what those command words mean. Otherwise, you're not really speaking the same language as the mark scheme there. And finally, spend some time getting your marginal gains. That looks like practicing those maths questions, practicing your practicals, and understanding what they mean and why you're doing them. If you can do all three of those things, I'm pretty confident you can get that A star there. Thank you very much. I think I'll pause over to here and now, and we'll talk about chemistry.
Okay, thank you very much, Kevin. We'll continue with the chemistry slides and then have time for questions at the end. So if I can ask everyone just to hang on to their questions until we finish both parts. There will, of course, be some overlap between chemistry and biology, but I've tried not to have too much repetition between the two, but of course there are going to be some overlaps between two science subjects. As Kavra mentioned at the very beginning, you often get some very generic advice from parents, from teachers, and maybe from websites that you've looked at. And again, they start to fade a little bit as time goes on. Things like manage your time, cram at the last minute, just memorize the mark scheme, use the internet, use the periodic table. These are very, very broad things, which everyone should be doing anyway, but they're not particularly helpful in terms of trying to get an A star. So there's about 8 or 9 things I've listed, which I think are more useful. But I'd also like to explain why those things are useful in particular. So the first one is the specification for each of the exam boards. So today's presentation is very much about all the exam boards. It's not specific to just one, but this particular image was taken from AQA just to demonstrate the point. The first thing to note is for this particular spec, it's fairly evenly spread with 35% on the first two papers and the remaining 30 on at the end. So not much in it. But with some exam boards, you might find it's 40, 40, 20, and that will obviously affect the way that you distribute your time and the way that you allocate your time from there. Typically in chemistry, you only have three topics. You have physical chemistry, organic chemistry, and inorganic. But of course, within those, you've also got lots and lots of small subtopics. And so the chemistry spec is fairly well, I guess, documented and pretty thorough. So it's something that you would have to split your time into at least three parts, but then maybe 10 more subdivisions after that. And as has been mentioned already, this idea of tracking, the only way that you're able to track it is if you go down to those subtopics and write down if you're better or worse at something like equilibria, things to do with kinetics, things to do with particle theory, and we can do that in the same way that was mentioned earlier in the biology slides. Okay. The second thing to note from the spec is that only some content is on some parts of the paper. So when it comes to revision here, you can see quite clearly that the first four chapters are in paper one, the next four are in paper two. But the problem is that paper three has anything in there. And the assumption, of course, is that by the time you've done paper one and two, you've already revised everything at least once. And so paper three should simply be the two merged together. Now, in practice, it's not as simple as that. Obviously, paper three is much more difficult because you have to know twice as much content. But it's content that you were due to know anyway for one and two. Note that the practical skills are also split in exactly the same way. So practicals, probably 1 to 6 for most of you, maybe 1 to 8 on some specs, will be on the first paper, then the second paper. And if some of you are doing Cambridge, then you'll have a dedicated practical paper, which is only practicals. So do look at the specification carefully and know which one of those is important. Now, I mentioned at the start that this idea of practicing exam questions and just memorizing answers and going through mark schemes is not solely going to get you the marks, but it will go a long way. And I think there are certain questions that will just come up year after year where there are some stock answers to a certain extent. Obviously, it's not going to get you an A star, but it could make that pivotal difference between the A and the A star if you're not losing these questions that come up year after year. So I would say that a good student who has done all the work they can possibly do will have done all of the exam questions for all of the past papers in their spec at the very minimum. And many students then go on to other specifications because there will, of course, be some new content, say to AQA, but maybe Edexcel or OCR or Cambridge have already asked their students that question. If you are practicing exam questions from other exam boards, you do need to be careful to make sure that the content is obviously on your spec because not everything is on all three specs. So it's just worth noting something like that. And of course, practice the exam questions on a cycle. So do paper one, then paper two, and then paper three as appropriate to your exam board. There are some core concepts that you just can't get around in chemistry. So obviously bonding is a core concept, things like the idea of equilibrium and chemical reactions, things like energetics and conservation of energy, mechanisms in organic, these sorts of things are common to every single exam board. And I don't think you can pick up a chemistry paper without seeing at least one or more of those on there. Some of these things are easy to explain using diagrams. You can see here this chart illustrates how the forward and reverse reactions achieve equilibrium. And then, of course, you can then write around the diagram. You can write down what would happen if the equilibrium is, say, raised or lowered, for example. How does temperature affect this? How does pressure affect this? But you should be able to do that for most of the core topics where you take a central diagram or a central word and then annotate around there to make sure that you have all the details that you need for that. And this, of course, is not exclusive to these four topics. This is just a list of some of the things that are core to all the exam boards. Certain reaction conditions in chemistry is just assumed that you know. So you need to know, say, certain catalysts for certain conditions, the optimum temperature and pressure for certain ones. So, for example, for the Haber process, hopefully you know that 450 degrees is a compromised temperature. And by that, you should know what happens if it goes higher or lower than 450. So just to answer that, for those who are not sure, so lower than 450 perhaps won't reach the activation energy. Higher than 450 will send the reaction backwards because you'll start to give it energy to break the bonds and go back into N2 and H2, for example. For pressure, you could say that if you increase the pressure, the forward reaction increases. But if you decrease the pressure, the particles are harder to collide together because they're not as close. And therefore, potentially, the ammonia will start to turn back into N2 and H2. So something like that you should know, but not just for the Haber process, but for all of the other conditions, for all of the other reactions that you are expected to know in your particular exam board. Okay. The yield of ammonia starts to fall. If you go too low, the yield of ammonia is still okay up to about 350, but then beyond that will start to fall again. So the 450 is considered to be a reasonable compromise between those two extremes. Organic is an entire chapter in itself. So obviously organic is anything that contains carbon. Carbon is such an important molecule. Sorry, it's not in this equation here. Carbon is such an important molecule that an entire chapter is dedicated just to carbon chemistry or to organic chemistry. So you can assume that about a third of your content, depending on the exam board, will be organic and a third will be inorganic, with the last bit being physical. So knowing how to draw these mechanisms is important. One of the things that we have said before is not just to memorize stock answers, but sometimes it is useful just to know the mechanisms for the most commonly asked questions. So if you can do maybe the top 10 most commonly asked questions and know how to draw those, then hopefully in the exam it will be something either, well, if you're very lucky, it'll be one of those that you've already done. If you're not so lucky, it will be something very similar, but you may just have to change out maybe one element or one compound, and then continue from there. But if you've done all of the mechanisms that have come up in, say, the last 10 years or so, I very much doubt that anything more than that can really come up apart from just substituting maybe one of the ions or something. Okay, so memorizing some of these would, I think, be helpful. I've already talked about the mistake log and tracking your mistakes. This was already mentioned earlier in the call by Kavram, but I just want to highlight it again in chemistry because it's just one of those things that across all three sciences and beyond probably all your other subjects, this is something which is, I guess, one of the most invaluable things you can do. If you don't know that you don't know something, to quote the Rumsfeld speech, then there's no way that you can improve upon that. So there are three things. You either know something and you know it. You don't know something, you don't know it, sorry, and you know that you don't know that thing. And the third one is the worst box. That's when you don't know something and you also don't know that you don't know that thing. Because if that's not even on your radar and it's not even on your list of things to cover, then it will just slip by and go under the list of topics that you need to revise. So having a mistake log and reviewing it, say weekly, maybe fortnightly for some of you, it just means that you can't escape those topics or escape those mistakes if you make some sort of log of those things. The required practicals, it's not good enough just to know the method. In fact, in many cases, the method is given to you in the exam, so that in itself is not what they're looking for. The required practicals involve lots of why, and I'm talking everything from the most basic questions, such as why was a conical flask used, going into more complicated things about why certain reactions happen or why certain catalysts behave in the way that they do. I've had students reach the end of year 13 all the way to the end of the course and not know the difference between why we use, say, a conical flask and a beaker in some practicals. And it's just because I guess they thought it was random, that you just pick up any glassware off the shelf and that there's no actual meaning behind it. Hopefully, most of you will know that a conical flask is designed for swirling, whereas a beaker is not. So that's one of the reasons you can give for why a conical flask is better. But of course, if you didn't know that simple fact, it's not something that you're going to be able to then write in the exam. So what I would get into the habit of doing is each time you write a statement for a required practical, I would write down why you are doing that thing. Why do some practicals have a glass thermometer and other practicals have a digital thermometer? Because there must be a reason for that. Why do we sometimes use a Bunsen burner and why do we sometimes use a water bath? Again, there must be some practical reason for why we are doing that. And why does the spec choose certain processes to focus on, such as the contact process or the Haber process? Why those processes? Because there are thousands, probably millions of chemical reactions that are taking place globally, but your spec has whittled it down to probably less than 10, and they've chosen the top 10 that they think are the most important. So we're maybe thinking about why your spec has decided that those are the ones that they want you to look at. If you are interested in buying these lab books, they exist for the two biggest boards for sure, so AQA and Excel. I believe they also exist for OCR, but I'm not entirely sure, so you'd have to check that online. These basically contain all the required practicals for each exam board. They only cost about £5 on Amazon, so they're not particularly expensive. And while it's not a sales pitch, it's obviously not my book, it's just worth noting that this does exist as an extra resource should you need it. So for someone who's maybe struggling with organization, keeping all the notes together, knowing which practicals are related to which chapters, this will help to summarize it very quickly for you with very little effort and very little cost. So that's maybe just something worth thinking about. As mentioned for the biology paper, there are just some calculations that you just need to know. There are not exact numbers for these across the different exam boards, but you can assume that up to 20% of a biology paper potentially could be mathematical, up to 30% of a chemistry paper, and up to 40 going towards maybe even 50% of a physics paper, depending on your exam board. So chemistry is somewhere in the middle of that. And some of you will be doing A-level maths, and this will just be second nature to you. Some of you won't have done maths since year 11, and therefore maybe this is slightly more difficult for you as a topic for you. The calculations themselves follow the same rules in the mark scheme, which is to always show the equations that you're using, always show the steps that you're taking to arrive at your final answer. And you want to make sure that you maximize the marks by showing everything clearly line by line so that the examiner does not have to go searching through lots and lots of messy answers looking for certain words. So maybe try to do the calculation or the steps in the calculation is like just in your head to begin with before you start putting pen to paper to make sure it's in there. And there will be certain things that you're just going to have to practice more than others. So once you've worked out how to work out how many moles you've got of a certain substance, and you've got just the mass number and the mass in grams, for example, once you've done that, because there is only one way to work out the number of moles using those two numbers, it's not something which you're ever going to have to do again. You kind of just need to memorize it's just mass over mr, and that's kind of the answer. But other calculations like Kc, rates, delta H values, these have so many different ways of being calculated that maybe just once is not enough. And as you move towards the right-hand side of that graph, I would say you probably need to practice more and more questions, partly so that you are seeing questions which could come up in the exam, but also so that you're not missing different ways of calculating energy changes, in this case, for delta H for Hess's law. The second thing to note is the periodic table is the only thing you get in the exam which is going to, I guess, help you as like an aid. So the periodic table is something which you should be able to explain inside out without any mistakes, what the group numbers are, what the period numbers are. You should know most of the mass numbers, I guess, from memories because you've used it so often, but of course still double check them when it comes to the exam date. And you should also know things that are not on the periodic table as well. For example, why the transition metals don't have group numbers and so on and so forth. The periodic table is like, apart from your calculation and pen and paper, it's the only thing you've got on the day of the exam to kind of help you as an aid in that. Mark scheme language. So we had there's this word that comes up in chapter 1 of most of your courses called nomenclature. I'll pronounce it in various ways. And I had students again all the way in year 13 asking me, what does that word mean? And the first thing I'm thinking is that word was used in chapter 1 of year 12. And the year 13 is asking what nomenclature means. And the reason for that is because once you go past that chapter, you'll never use that word ever again. I certainly won't use it in day-to-day language ever again. And so it's important to go through mark schemes and go through the spec so that you are familiar with the sort of notation, the sort of words that they are expecting, not just to maybe use in the questions, but for you to use in your answers. And they're both equally important. Because if the question asked about nomenclature and you don't even know what that word means, then of course you've got next to 0% chance of answering it. And I picked that word just because it's one that a student asked me recently in class. But there's hundreds of words across the spec which are not used in day-to-day life. Okay. And you'll get this from the mark scheme, you'll get this from the syllabus, you'll get this from past papers, but you essentially want to match the language of these mark schemes. A common thing I say to my students all the time is that you can't change the mark scheme of the exam to fit your answer, but you can change your answer to fit the mark scheme of the exam. And it, of course, has to be the latter of those because the mark scheme is not going to adapt itself around your language, which means that your language has to adapt itself around the mark schemes. Okay. This idea of consistent revision, again, briefly mentioned in the biology, but just to highlight it again one more time. This idea of little and often, many of you will have heard the 20-minute rule about how there's a certain amount of time, which for some of you might be 20 minutes, for some might be an hour, but there's a cut-off point for everyone where you start to get what we refer to as diminishing returns, essentially. So that 1% rule that was mentioned about adding these iterative improvements, you're much more likely to do that if you do revision in batches, if it's organized, if there's some sort of plan behind it, and you increase your marks by just 1% each time you move to the next day. And of course, if you keep doing that and keep doing that, the growth curve will grow exponentially. So you can only get better and better as you learn from previous mistakes. The problem, of course, is if you try and do everything on a single day, let's say, for example, you cram all 8 papers in one day, you haven't given your long-term memory any chance of memorizing anything, but you also haven't given yourself time to improve from one paper to the next. So the reason why you have to start the papers maybe 10 weeks in advance is because you want to leave a couple of days between them to see if you've learned anything. And then you do the next one, leave another couple of days. So 10 papers is not 10 days worth of work. It may not be 10 weeks necessarily, but it's certainly not 10 days. But it's somewhere in between those two extremes. So again, 5 weeks, 10 papers, something like that might be reasonable. And that's just for your board, don't forget. There are other papers that exist for other boards. You might also want to do the AS papers as well as the A2 or the A level papers. So it's worth noting that when we say to these 10 pass papers, that is the absolute bare minimum. There may be 20 if you do your AS papers, and there may be as many as 60 if you do all three exam boards. So these papers can stack up very, very quickly. And that brings me back to Theo.
Great. Thank you
Thank you
so
very much.
much, Hiran. And I think everyone watching will agree that you both squeezed in so many brilliant tips in just a short space of time. There's a lot covered there. Um, so thank you both very much. That was really valuable. We will be sending out a recording of this to everyone who's attended and everyone who's registered, so that you can rewatch it and share it if you would like to with your classmates, just in case you missed anything. And I think what both tutors have said about keeping organized is really important. However talented you are in your subject of biology, whether it's maths, whether you're doing chemistry, whatever other subjects you're studying, if you don't have that organized and disciplined approach to your revision, your studies, then you may still underperform your potential. And also don't overwork. So you have lots of people, I know at my school there were lots of people who were boasting about spending 12, 13 hours in the library, working extremely hard, but that also is not terribly effective because if you burn out, you don't give yourself the chance to process information, let things settle. Your brain needs to be working in order for you to really revise properly. So take care of yourself, take lots of breaks, and that means you need to start quite early and be organized with your time. So we'll go through some of the questions that people have put in the Q&A. There are 15 at the moment and growing, so we'll get through as many as possible in the next 10 to 15 minutes or so. And I'll go in chronological order. So the first question is about the specification, I presume for biology, but it could also be for chemistry. So Kavarang, are you still there?
Yep. Can you hear me?
Yes, I can hear you. Thank you. So, I've got a question from Carson, which is, may I ask for AQA? This could also be for Hiran, I'm not sure. Are there any essay questions in the syllabus? Because I tried to search for them, but it doesn't seem to be present. I presume it's more likely to be in a biology paper than a chemistry paper, but I might be wrong.
Yeah, so there is a 25 mark essay question in the biology paper, so for AQA. And you can, I think someone else posted like how do I find them? There are some like good Quizlet flashcard ones where they don't have the exact mark schemes, but they go over most of the topics that will appear on the mark schemes. So I think it's worth looking on Quizlet or asking your teachers as well. I'm sure they've got a bank of 25 markers that have appeared in the past.
Brilliant, thank you. Someone has asked, are there any tips for someone who doesn't do maths A level? Hiran, should we go to you for that one?
Yeah, I think for this, I mean, there's a couple of things that you can do. The first is each of the exam boards has produced a guide, which is literally called Mathematics for Chemists and Mathematics for Biologists, and both of those exist. I know on the AQA website, they're completely free PDFs to download, and they're essentially designed for those students who are not doing mathematics. The chemistry one is 160 pages long, so that gives you some indication of how much math we're talking about, but it is very comprehensive. It covers everything from tables, graphs, scale factors, calculations, there's worked examples, there's diagrams. It's essentially designed so that you can't miss it. And even if you are studying A-level maths, I'd recommend that you have a look at that booklet anyway, because there'll be certain things that are not in the math spec, which maybe are required in chemistry. So yeah, there's definitely free resources for that. And in the same way that I mentioned the other book about the practicals, I know CGP also produce a book that's called Mathematics for Physics, Mathematics for Chemistry, and Mathematics for Biology. So again, they're only about £3 or £4 each if you buy them via your school. So they're not expensive resources to get hold of.
Brilliant. Here, I'll stick with you for the next two, and then
Yeah.
we'll move back to Kavarang. Kai's asked, for students who are doing an extra year, maybe starting chemistry and biology next year, what's the best way to prepare before starting the courses? So I presume they're really keen, they want to get a head start before starting the A levels. How should they start to kind of cover material, or should they?
Okay, so a couple of things. So if you're aiming for the A star grades in these, I guess it's it's implied that you should be able to get a grade 9 at GCSE. So the first thing would be to make sure that your GCSE knowledge is certainly up to a grade 9. Um, that of course means that you will get in the 80s as a percentage of your exam. But then it's a case of, I guess, filling the gaps after that, and just making sure that 80% is closer to 90, maybe, so that you're closing that gap between the top end of GCSE and then the bottom end of the chemistry. There are pre-courses you can do. I know some schools have just again made them freely available on their website where they set summer work. I know certainly at the schools that I've worked at, we once we know who's applied for each course, we will set work for them to do over the summer, and then they bring that work in with them in September. I don't know many schools that don't do that, so I'd be very surprised if their sixth form or college does not offer that sort of service. But I think the biggest issue is if you don't know what you're doing yet, or if you don't know what school you're going to, then perhaps you're not going to be there for them to know to give it to you. So this is much easier for those that are staying on at their existing schools. If you're changing sixth forms, or if you're applying to a different sixth form for your A levels, you may need to contact them directly to ask if they can provide something for you, so that you're on their radar for that sort of thing.
Brilliant. And I'll stick with you for this next one because it's specifically about inorganic chemistry. How should we memorize the MUST equations?
The memory game is one of these things where I'm not a huge fan, like I said, I think in the PowerPoint, of just memorizing things, and I think understanding it is better. But unfortunately, in chemistry, there are just certain things that you do just need to memorize. And this is different for different people. So the questions that you're asking essentially could apply to uh, anything else that he's memorizing. But the most effective methods, according to research, are things like use of color. We saw that on the biology slides that everything was highlighted, everything was color coordinated. There's a huge amount of research to say that if you can link certain things to certain colors, you're more likely to remember it. So, as an example, if you're talking about a halogen that involves fluorine, you might want to make it in green because fluorine's green. Sorry, it's not. Sorry, we start again. Fluorine's yellow, sorry. Chlorine's green. And so on and so forth. If you're writing about bromine, you'd write it in orange. If you're writing about iodine, you'd write it in grey. There are certain things that certainly trigger your memory better in exams, and use of color is definitely one of those. The second thing I know is not particularly helpful, but starting early is always a good tip, just because there are so many of them to get through. We're talking possibly 30, 40, maybe 50 things that you just need to memorize. And of course, if you only have 50 weeks in the whole of year 13, that's including all the holidays. You're talking about one a week to get through it all. So for those of you who haven't done that, I'm not saying it's too late, but you'll need to do about 5 or 6 a week now to catch up in time for the exams, if you're still at that memorizing stage.
Great. And I would just add to that, as well as colors, there's also if you're quite a visual person, then I would really recommend using different ways of laying out the material. So when I was trying to remember stuff taking exams, I did a master's in psychology. There's lots of kind of content to learn a couple of years ago, and I used a lot of mind maps, but then I represented the information in slightly different ways. You might draw a diagram, you might write it out in long form. Then you might draw something a little bit like a mind map where you connect different topics and ideas together, so that it embeds in your understanding in a few different forms and you don't become bored by just writing out the same stuff. Um, and another question about technique, I guess, which could apply to either biology or chemistry, but Kavarang, I'll come back to you with this one. This person has asked, I can't master exam technique for most types of questions. So they're very good with understanding and knowing the content, but they're not very good with exam technique. What are your best like technique approaches?
Yeah, I think we touched on this a little bit in. So I have two ideas here actually. Number one, I think working through the mark scheme is sometimes a good idea, and I think like that's where you can pick up a lot of tricks and patterns for your exam technique. However, I also think like sometimes there's just no substitute to brute force doing some questions and finding what sort of works for you. Because you'll find that you have patterns when you're answering questions and the ways you're thinking, and try and break down your approaches to questions. I think that's where you'll find, yeah, I think that's where you'll find your best approaches. Um, yeah, Aaron, you have anything else to add there?
Um, I think there's a huge amount of value in going to the mark schemes. I think if you have a past paper, even if you can do it without the mark scheme, going through with the mark scheme and almost just like copying across or transcribing across the answer from the mark scheme to the paper, it again, it's that 1% return thing. It's obviously not going to get you an A star in its entirety, but what if just two or three or four of those marks of those questions that you've done is enough to tip a B to an A or an A to an A star? And I do think there's real value in mark schemes, particularly for the extended writing one. I know you asked earlier regarding biology, but also in chemistry, it's not quite extended writing, but there can be some 6 markers and 9 markers, which is as close as it's going to get to essay writing. But knowing how to structure them, what sort of words to use. Sometimes words are in bold or underlined, which means if you don't use that exact word, you don't get the mark. These things you're never going to get unless you have the mark scheme next to you. Um, One of the worst things, I guess, is that if you know the answer and you write it perfectly in the exam on the paper, but the mark scheme was looking for just a single word, whether that was halogen or alkane or alkali or whatever it might be, and your answer is word perfect, but you don't have that word, then we have a problem because you've lost a mark for something which you should have got quite easily. And yeah, the only way to do that is by going through mark schemes and looking for these bold and underlined words. But yeah, I'll just repeat that that's both for biology, chemistry, and of course physics, maths, and lots of other subjects as well.
Cool. Thank you very much. So I think we've probably got time for a few more questions, maybe up to 10 questions, because a lot of these cover the same kinds of topics. So one question is quite specific. Let me scroll down and find this again. Okay, so one's quite specific to biology AQA. So this is back to Kavarang. For biology, how would you go about finding the explanation of how to do the maths questions? Because the mark schemes only show the answers. So how do you find out the techniques?
Yeah, I think there's two ways to do this. Number one, sometimes it can be quite difficult if you can't find the mark scheme answers to chuck both the mark scheme as well as the question into sort of chat GPT or something, and it will usually give you like a way to work through. Alternatively, something I would look at is Hiran mentions the maths for biologists that AQA has. Most of them will have sort of worked answers or worked examples for a lot of your biology questions. For example, the Hardy-Weinberg equation. That can be a little bit tricky, but if I know for a fact they have it on physics maths tutor and the AQA biology maths for AQA biologists booklet, they have a way to work it out. And most of the variations on that question in your exam papers will just be sort of switching of different numbers. It'll be the same marks every single time. Obviously, there's different variations for a few of the other topics. I'm thinking of, I believe I'm thinking in OCR for the heart topic. They have slightly different mark schemes as opposed to the other exam boards, but for the most part, you can find most resources either via AI or just look up the sort of mathematics for whichever board you're doing.
Perfect. Great, thank you. There's a question about the use of flashcards. There's actually a few questions about flashcards. So it'll be good. Hiran, maybe you can comment on, do you think flashcards are a really good way to revise? And also someone's asked, should we use AI to write the content for each flashcard?
So flashcards have their place, I think. I think the only limiting thing with flashcards is just the quantity of them will be so big by the end of the course that it may as well be like a dictionary or an encyclopedia by the end. So flashcards in themselves are not useful at A level if you've got so many that you can't then look back at it. I think one of the origins of this is just because people use them in Key Stage 3, they potentially use them in Key Stage 4, and then they think they can just continue with that method. And it's not anything wrong with the method itself. I think just knowing the volume of flashcards you're going to both need to not just buy, but also read as well at the end of the course is just so voluminous. However, if you switch out from flashcards to mind maps, you suddenly have a very different picture here because if you have A3 sheets and you can fit, say, 10 flashcards worth of ideas onto a single A3 sheet, those are easy to then tile up on the wallpaper, stick on the wall, wallpaper paint, and you can then look at those from a distance while you're working on your computer. They're also much easier to fold in half and put into folders, whereas I find flashcards just end up all over the place. They're not in any sort of order. Whereas mind maps can be turned almost into a booklet. So if you do one mind map per chapter, then you have 10 mind maps in total. You staple it in the top left corner, and suddenly you've got a booklet of mind maps. And that's much easier to do than personally, I think, flashcards. But I think it's one of those, horses for courses type thing. It's each to their own in terms of how they would learn best.
Brilliant. So I think we're coming up to the end of our time, but there's two kind of broad questions which I think cover the majority of the remaining ones. I think they're useful for everyone. So the first one is when should people start revising for their A levels and what should that look like? So how many hours per day would you recommend? Hiran, should we stick with you for that one?
Yeah, I'm good. So I was going to interrupt and just mention that I'm obviously aware that some students are doing their exams this June, so I don't want to panic anyone by telling anyone they should have started 9 months ago or anything like that. I don't think it matters in terms of I'm going to split it into year 12 and year 13. So for year 13s, start today. That's what I would advise if you haven't already. Of course, many of you will have started already, and for those that did, it would likely have been around the mock exams when you started revising properly, and then the corrections to that, and then the last few chapters. Um, you need to remember there's two types of revision going on in parallel. You're revising week by week for in-class assessments, for in-class tests, for things like mock exams that you might do in year 12. That's your day-to-day kind of revision which you have to keep up with. Otherwise, you won't get a high predicted grade and will unlikely to get a place in medicine anyway to begin with. So that's just your day-to-day running of revision. For the final exams, you can never start too early. And I really do mean that, like week 1 of year 12 is when you're really starting. But for those of you who are asking specifically now in this position for today, for the exams this summer, my advice would be to take the notes from this meeting and start, well, not even first thing tomorrow, start first thing tonight after this call, I think.
Great. Kavaran, do you have anything to add about that? So how long should you spend revising, maybe as like a typical day?
Yeah, I think I definitely fell into a trap in year 12 where my mock exams suffered a little bit because I started quite late for my examinations. I think I have to echo what Aaron said. Sometimes there's no real substitute for hard work. You kind of just have to get on with it. And now is the best time rather than tomorrow, sort of thing.
Cool.
As for how many hours in a day, I think you have to measure how much you can stomach, really. I think I know, for example, for myself, 2, 3 hours in, my focus is going to start to wane. So I try and give myself breaks, at least in between that 2, 3 hour session, as well as afterwards, give myself a longer break. Try and reward myself. But don't try and we talked about earlier, try not to fall for those people who say they do 12 hours of revision a day. I feel like a lot of that it's very, very difficult. Try and understand what works for you and stick to that, really.
Great. And then the final question, a couple of people have asked this, but I think it's a really important one. People often focus on the kind of the details on, what should they do with particular types of questions. A lot of the time you can bring those questions to your teachers at school. Something that I find isn't really covered in school that much is how do you keep motivated and how do you keep kind of positive and keep yourself going through what can feel quite arduous and quite repetitive? Maybe we'll hear a bit from both of you on your tips on how to keep motivated. So Hiran, should we start with you?
Yeah, I mean, motivation, this is $1 million question, isn't it? We have this in teacher training courses, how to motivate students. I mean, even teachers don't have the answer to this. I think sometimes a break is as good as just continuing ahead. I think sometimes if you're lost in a mess of, what to do, how to do it, it's a very ineffective learning environment to try to do it while you're stressed or anxious and so on. So sometimes a gap is appropriate if it means that you get better returns in the next few days. I would say don't lose sight. I mean, these courses have been running since A levels began. This is not a new course like computer science, for example. These are very well established courses. People have been doing them for decades. There must be a way forward. And it's sometimes it's just maybe changing the path that you're taking, changing your plan of attack, changing your methods, and finding something that works for you. I would think that most reasons why students are maybe lagging behind or disappointed or not motivated is because they're not doing something right. They're not learning in a way that's effective for that particular person. But once they find that and they regain their spark, continuing ahead is much easier. And that's no different to any aspect of life, I guess. We all have that with whether it's household chores, whether it's work, whether it's just life in general, I guess. Everybody has to find a way that works for them in particular, not just copy the crowd, as it were.
Yeah, and I think, like Kieran said, I don't think there's a one size fits all answer for this. And I think for me, I suppose I can give my example, especially during my A levels. Something that worked for me was like I was really into debating, and it would be like a Wednesday sort of after school activity for me, and as well on Saturdays. And you get to go to these universities and take part in these debate competitions, and that kind of grounds you for why you're doing A levels in the first place. Like, yeah, I want to go to these universities, I want to study this, and it sort of makes it all worth it. Something that reminds you, but also like doesn't take up that much of your time. I think is a good motivator and kind of takes part in that entire cycle of the A levels, really. Yeah.
Brilliant. Thank you both so much again, and thank you everyone for joining. There's still lots of you on the call. Just to let you know again, this recording will be going out, and if you have questions that you didn't get to ask in this, I'm sorry we couldn't cover all of them. Feel free to get in touch with the Medic Portal, info@themedicportal.com, and we can get back to you. We can organize a phone call. And if you'd like some one-to-one support with your preparation in the next couple of months, that's something we can organize as well. But yeah, thank you so much here in Cabarang, and thank you everyone for joining, and all the best of luck with your revision for biology and chemistry.
Thanks, yeah. Thank you, guys.
Thank you.
Thanks, Thea. Thank you for joining.